Okay, so today's lesson is going to be on classifying polygons. So this will be the first lesson of the new unit, polygons and parallelograms. So before we begin, we'll start with discussing what is a polygon, what makes a polygon. The definition of a polygon is a two-dimensional shape with straight sides. So what does that mean? Some of the characteristics is that it's a closed shape. There can't be any openings, such as this, right? There are no curves, only straight sides. So in this shape, these are non-examples because there's a curve. A circle has one big curve, right? No sides. So there can be no overlapping of sides. Right? So, such as this. Those two sides, it's kind of like two triangles touching, but the overall shape is not a polygon because the sides, you can imagine this is a side and this is a side and they're crossing in the middle, so that is not a polygon. All of these examples that you see here, all of these examples are polygons. They're all two-dimensional shapes with straight sides only. No curves, no openings, no overlapping. So, once we identify what is a polygon and what's not a polygon, we can talk about two different types of polygons. We have a convex polygon, and down here you can see concave polygon. A convex polygon is a polygon with all of its interior angles, so that's angles that are on the inside, right? Interior angles that measure less than 180 degrees. Right? So when we talk about interior angles, we're talking about inside. This is less than 180 degrees. This angle here is less than 180. Right? All of the interior angles are less than 180 degrees. So another way to think about this is that all the angles point, spell that correctly for you, all of them point outward or flex, convex, flex, out, right? So they point outwards. All these are like little arrows that point out. Another way to think about this is that all of the diagonals are inside. Alright, so what's a diagonal? A diagonal is a line that connects two vertices or two corners of the polygon that are non-adjacent. Alright? So all of these that I can draw from one corner to the next, in all of these shapes, for me to get from one corner to the next without going to the one right beside it, making it a side, all of those are on the inside. That's a property of a convex polygon. Whereas, you see if I draw this diagonal from one corner to the next, that one's on the outside, right? It's outside of the shape, and therefore it is not convex. concave polygon are all the rest. So it's a polygon with at least one interior angle the measure greater than 180 degrees. Right? It just means one. If one of them is greater than 180, you can see this interior angle is more than 180 degrees. So it is concave. You can see this has a diagonal on the outside, so it must be concave. Right? Some of the facts and characteristics is that you have at least one, so you can have more than one angle that's greater than 180, but you have one angle that points inward. Another way to think about that is that it caves in, right? You see these, this side, it's like it got pushed into the shape. It got caved in, right? Or like we talked with the convex, you have at least one, you could have more, at least one diagonal on the outside. At least one diagonal on the outside. I'll just write that nicer for you. So again, this diagonal's on the outside, that diagonal's on the outside, this diagonal's on the inside. Doesn't matter. As long as there's at least one on the outside, then it's concave. Right? So you see here all the examples of concave polygons were non-examples of convex. You have to be one or the other. You're either convex or you're concave. No polygon is both. So if we flip over to the next page, we can talk about another type of classification. So when we talk about polygons, we can call them equilateral, right? A special category of polygons are equilateral polygons. Equilateral polygons are a polygon with all of its sides of equal length. Right? Equilateral. Lateral means side. So equal sides. The polygon, all of the sides of the polygon are equal, then it's equilateral. Right? So you want to check and make sure that all of the sides are marked. If one of the sides are not marked congruent, if one is missing, then it's not equilateral. You can't assume that the one that's not marked is equal. So check to make sure they're all marked. You also want to make sure that all sides have the same mark. Or the same number. Of marks. For example, this pentagon, these all have 3 marks, and this one has 2. So because these are not the same as these, it is not equilateral. Just because they all have a mark on them does not mean that they're all the same. All the marks have to be the same length. So you see in this hexagon, all of the sides are marked, and they're all marked the same way. That makes it equilateral. Another characteristic, another type of polygon we could talk about would be equiangular, right? Equiangular is just what it sounds like. It is a polygon with all angles of equal measure. So they're all the same. All the angles have been marked. These are angle markings, meaning that they're all congruent to each other. So once again, things that you want to look for and make sure that you're checking for is that all angles are marked. Now you could also look for numbers, make sure that all the angles are the same number. That would also be representative of them all being equal measures. Again, you also want to check that they all have the same number of congruency arcs, right? So for example, this quadrilateral here has a 1 mark and a 2 mark. Those are not congruent to each other. So it's not equiangular. Okay? So equilateral, all the sides are the same. Equiangular, all the angles are the same. And last we have a regular polygon. A regular polygon is a polygon that is both equilateral and equiangular. So previously when we had been discussing triangles, we said that if it was equilateral, then it had to be equiangular. Well, that's not true for all polygons. The only thing that that's true for is triangles. So, a triangle that's equilateral has to also be equiangular. So this triangle here is marked equilateral. So this is actually not a non-example, but it is in fact an example of a regular polygon. That's only true for triangles. If I mark the angles congruent, then you know the sides are congruent. If I mark the sides congruent, you know the angles are congruent. That's true for a triangle, but it's not true for any other shape, any other polygon. So, again, you look to make sure that all sides are marked the same. Right? They all have to have a mark, and that mark has to be the same in every angle and on every side. Right? And you need to prove both equilateral and equiangular. Do not assume if it's one that it's both. It can be one or the other. Okay, so that's the notes we have. You need to be able to classify, tell whether or not the shape is a polygon or not. Then you need to classify it into one of two categories, either convex or concave. You also need to be able to then look at it and evaluate, is the polygon equilateral? Is it equiangular? Is it both? Is it regular? And then the last, if it's not any of those three, then it would just be a polygon, just a plain polygon. So in the next couple pages, you have some practice problems that I want you to do on your own. The first 6 here are matching. So you're looking at the word, finding the definition. And then these 8 problems, you are just telling me, is it a polygon? If not, tell me why. Which of the properties of polygons is it missing? For example, number 7, this is not And the reason it's not a polygon is that it's open, right? That does not close, therefore it's not a polygon. It's what I want you to do for these next 7 problems. On the back page, you're going to use the number of sides to tell what kind of polygon the shape is. Then state whether the polygon is convex or concave. So you do need to know 3 sides is a triangle, 4 sides is a quadrilateral, 5 is a pentagon, 6 is a hexagon, 7 is a heptagon, 8 is an octagon, 9 is a nonagon, 10 is a decagon, and 12 is a dodecagon. You can look that up if you need to. If you have trouble with that, do tell me, convex or concave. You need to be able to tell the difference between convex and concave. So try to name each shape based on the number of sides, and then tell me, is it convex or concave? And the last exercise here with these 6 problems is to tell me, is it equilateral? Is it equiangular? Is it regular? Or is it none of these? So, do these 2 pages for practice. I expect these to be completed and turned in when I see you in class again.